Hi guys, hope you're well. Today will be a short one. I want to discuss what are abstract classes, interfaces, and types in TypeScript. And if we don't know each other, hi, my name is Tomasz. I'm a former tech lead and manager. So before we go deep, a quick reminder, what is a class in general? So it is something like a very robust blueprint of whatever functionality we want to achieve. It can exist multiple times in a single program. It can be instantiated. So there can be multiple instances of the same class, and they are completely independent of each other. This means if we have a class named person, we can create multiple other people based on that class. And they will all have different properties, but they will be rooted, they will be sourced in one particular blueprint, which is a class person. Classes are basics of object-oriented programming, and there are tons and tons and tons of rules how you should and shouldn't work in this particular paradigm. I will not discuss these details today, but I will discuss what you should and shouldn't do with abstract classes and with interfaces. And like I said, uh, then we will look at types, which are theoretically the most potent creations in TypeScript. Right, so when we talk about abstract things in general, in English, the word abstract has several meanings, but the most important, it can be a summary of something and an theoretical illustration of a concept. So when I describe you an idea, like for example, we meet and I tell you how I want something to be done, I am providing a form of an abstract to you. It's not tangible, but you can imagine how it will work, how it will look, how it will behave. It's very similar in programming. We create an abstract class in which we describe what it should consist of. And we leave to other developers to fill in the blanks. Let's jump to the IDE so you will see what I'm talking about. All right, so let's start with abstract classes. As you are probably aware, we are in Spooktober. So what other game to start if not Castlevania? Let's try to create a abstract Belmont. So what we want is we want to create a abstract class that will serve as a blueprint for other Belmonts, right? But we need to make sure that our character is a Belmont. So if Alucard will sneak in, we need to tell him that no, sorry, you are Tepesh, you are not a Belmont, so you're not here. So export abstract class, and I like to name my classes abstract something, so it's just easier for me to make a distinction between abstract and solid classes. So what we need name, will be string. We need what? Health points. Let's say health points, and we can make this protected, so nobody will mess with this. In abstract classes, you don't really use private fields or private methods. I mean, you can, but that's kinda beside the point because you need you define a blueprint. So everything that you define has to be public so it can be used, right? It can be used basically. Right, so we have name, so obviously set name. No, sorry, maybe not set name because we'll have it in constructor, right? So we have this and obviously okay. And now what we want attacking, right? So abstract attack, right? And we are just providing the signature. there is no implementation here. Attack, abstract, I don't know, big sub weapon, weapon string also void. So let's have side web sub web weapon is string or undefined, and it won't be abstract because all Belmonts have ability to pick sub-weapons, if I'm not mistaken. So we can implement this. This is very important. We can implement this. Let's put it higher so we have abstract methods on the bottom. Right, so we also want to verify the the name. So let's say verify name. Name will be a string and it will tell them boolean. So we can just say name index of Belmont doesn't equal -1, -1. So even if this guy will be named Belmont, it will be fine. And in here we want to say if this verify name throw new error sorry name is right. So now when we are creating this, when we will be creating the class, we will say that, okay, this guy is not abandoned if he is not. But we have also, like I've mentioned, abstract constructs here. So we have these two constructor and a pick sub weapon as and verify name as public, because having this private, I mean, it sorry, it can be like this and then it will be hidden. So okay, we can leave it like this, but it really doesn't make a lot of sense, to be frank. That's okay, let's leave it as private just to be, to have fun. But you cannot declare something as abstract private, because there is no point. Abstract private private cannot be used with abstract. Exactly, this means that we cannot declare something as private and expect this to be in a blueprint. You only declare things that can be used later on. So we have attack, we have abstract, let's say defend, attack, number, void. So let's say that one person can defend themselves and another cannot, like Gabriel can block, right, in Castlevania Laws of Shadow. Okay, so we have this. Let's now test this. So import expect and test. So yeah, and it'll obviously import abstract Belmont. So okay, so test. It should uh, instantly. Ah, right. So this will be cool because this is where TypeScript and JavaScript clash. So we can say const Trevor equals new abstract Belmont. Sorry, abstract Belmont. Is this signature correct? Correct. And we are getting information that cannot create an interface of an abstract class, right? But if we will create public get health, return this health. Okay, correct. Sorry. So if we now go and ignore this with ts ignore, and we will say expect Trevor to be fine. Now I mean expect to get health to be 100 and run this, it will be fine. So this this line right here is just a syntactic sugar. But what will happen if we will run a abstract thing? So let's go back here and let's just go Trevor attack. And it will simply not a function because it's not visible to JavaScript unless it is defined, unless it has a body like here. So what we do with abstract class? Well, we create a regular class. So class Trevor extends abstract Belmont. And in here, we define methods that we are missing. So we are missing attack and defend. So public attack, and we can just say Trevor attacks, doesn't matter. And public defend and exact, sorry, this health minus minus attack. So it will be decreased. And right, but if we would like to get the value, we would have to use simple get health. That doesn't matter for now. So as you can see, this is it doesn't return any errors. There are just unused class. But if we remove this, we will get a problem that non-abstract class, so a solid class, does not implement abstract member defend. Like it does not implement inherited abstract member. So it has to implement everything that is marked as abstract. This is like a requirement for a class. So it should attack, let's say, and new Trevor Belmont and Trevor something like this, right? And it works. What do we have? Pick up sub weapon. Okay, so do we have function to get sub weapon? No. So let's probably get sub weapon. Return this sub weapon. Okay. Okay. So test it should be sub weapon. Right? For demonstrational purposes, uh, you don't have morning stars, I believe. Holy cross, of course, or holy water, or throwing eggs. Never mind. So we are testing the implementation of the abstract. So in abstract, we already have this, so we don't have to do this by ourselves. And it also works. Oh, and let's verify this. I forgot. So test it should throw when it is not a Belmont. And let's just create a class. Alucard extends abstract Belmont. But in here, let's say Alucard has better defense. So as you can see, the body of defend differs. So we can use this and we can change the implementation according to our needs. But his name is Alucard Tepesh and 90. I don't remember how much health he has on the start of Symphony of the Night, but expect inspect Alucard, I don't know, defend and to throw. It probably will throw even earlier. Exactly, Alucard, but it did throw even earlier. So I guess we should do this. I be frank, I am not good with testing throws, but yeah, it throws like this. So we can write this class, right? We cannot say okay, Alucard, and he extends the boundment, and then we can implement this. But we have this private, this hash hash check that will say okay, it's not a boundment. Sorry, I am throwing. All right, so now it's really finally it with the abstract classes. So let's jump to the interfaces. If you think of the word interface, I'm sure you see in your mind some kind of a device that you can interact with. For example, a keyboard is something that is called HID, Human Interface Device. So this is a device that provides an interface for humans to interact, right? We type on it and something happens on the computer. If it is connected, if it's not, then it's not an interface. It's just a useless tool that can bring a lot of fun if you are sick and bored and you just want to tap on something. Um, but also, if you have a computer display, it's also a type of interface, but it is not an input interface because we are not inputting stuff, but it's an output interface because it outputs things to us. It's very similar with programming again. So if we have an interface, we can describe what we want in there and leave the implementation to someone else or to future self. That's again kind of your problem. The difference between abstract classes and interfaces is that abstract classes can have bodies in the function. You can fill in some of the blanks if they will be often repeated. And with interface, you don't get to do this. You can just say, okay, this class should have made method A, B, C, and D, and they should accept such parameters and return such objects or such types or whatever. And that's that. That's all you can do. Let's go back to the IDE and I will show you what I mean. Okay, so for the interfaces, I think we can go with something even scarier than Castlevania, and this is, of course, work. So let's create an employee.ts. And okay, let's close this. Sorry. So, as I've mentioned, interfaces only describe things. And I like to name my interfaces I something. So, short for interface. So, I employee. I believe this is a pattern from C Sharp or something like this. I don't really remember, but I really like this because it provides a clear separation of what is what, especially when you are importing and you don't use import type in TypeScript. Okay, so in here, again, name, string, salary, number, and we want what? These are all public fields, by the way. So they will be available to us to pick. Name, salary, what else can we want? Um, give bonus. Bonus is a number, returns void. Uh, calculate bonus. No, not even with this. So we will use salary. All right. So we now again create class employee, And instead of writing extends like we did with TS, sorry, we did with after classes, so it was class Trevor extends. We will write extends I, sorry, not extends, implements I employee. And from the get-go, you can see that it is on red, and class employee incorrectly implements interface I employee. Type is missing the following properties: name, salary, give bonus, calculate bonus. So what we can do is we can obviously create these things, right? Name, salary, number, uh, constructor. Yeah, this will be fine. Constructor, give bonus. So you can see that it actually suggests me stuff. So this will be this salary times 0.1, so 10%, salary times bonus equals, and this give bonus of bonus. All right, so we have this, right? And as you can see, we have to write everything down. Every method has to be written. And this kind of makes sense if your classes that are implementing the interface won't repeat themselves very often. So if you want to make sure that every piece of this class can be adjusted to your needs, instead of having some blueprints and some body like we have with abstract, in here we have only definition, nothing else. This is literally an interface, so it tells us what we can do with this. That's that. Okay, so let's try writing some tests for it. Employee test, yes, import this, create test, and import employee. All right, so I won't expect. So test instantiate, right? So we can say const John equals new employee John, and he earns 1,000 of, I don't know, rupees. And expect John to be instance of employee, right? Something that is very simple. And we are basically, I would be frank, we are kind of done, because, we can write tests for it and it's totally fine. So, test gives bonus, right? So again, we are creating a John, calculate the bonus. And you know what? I don't feel this is good, so just let's return this, and let's not do this. But this is still fine. We delete bonus, and now we can even remove calculate bonus, and we can mark it as private. Also, one thing, we removed it from here, and it still resides in here, right? And it is fine. You can have more things in your class that your interface defines. This is fine. This is okay in TypeScript. Right, so private, just to make sure that nobody messes with this one. Works, cool. Yeah, so these are interfaces. If you need to have a blueprint that will be different, that the implementation will be different from one another, If you need something more repeatable, go with abstracts. If you need something that will be unique but will still have one root, go with interface. Interfaces are also great to describe things for React. For example, we can we can create interface props, and we also can have like get name string, right? And then we can have I don't have React in here, but uh, const person props, yeah. Because again, we are describing an interface. We are describing how this can be interacted with. So yeah, that's that for the interfaces, and we will jump to types now. All right, so we are done with the object-oriented stuff. You can now slap C# or Java sticker on your laptop and nobody will know that. You just know TypeScript. But let's jump to more functional word. But not only functional, but also imperative. Types in TypeScript are probably the most potent, the vastest. I don't know if vastest is a word, the most vast. I don't know, but it's the largest group of types. I don't know how to name this, but it's the largest group. So everything that is not an interface and not an abstract class goes in there, from primitive to function definitions to object definitions to, I don't know, merging of types to, I don't know, excluding types, whatever. Let's jump to the IDE and I will show you exactly what I mean. Okay, so I don't really have any theme because types are basically too vast to narrow it down to one movie, a franchise, or frightening experience in your life. So types are, like I said, extremely potent, extremely vast. It can be they can be used to describe basically anything. So we can say type result is Boolean, for example, right? And now we can say that we have a function verify string and it returns result. So return verify length greater than 0, for example. And we can say that, okay, this is a result, right? It can be a Boolean, it can be a number, but this will be a problem, so we need to change this. But it also can be greater, can be like status exactly. So let's say status number. And if return status 200, message success, otherwise return 400, whatever, yeah? So this is the basic type. It can define something that you don't, because we could do, we could do this, right? And it will still be fine. But if we want to have like, I don't know, another function result, and now you want to, I don't know, return uh, something like this, yeah? Basically, it does the same, but it is simply shorter. So again, we can say result, like in here, but we can also do this, right? Right. What else we can do is we can type function. Let's say type some function. Hold on, it will be a number. B number returns no number. And now if we want to use this, so const sum is some function. And you see, we didn't have to put any types in here because it inferred the type from here. It took it, so it said, okay, A, B, and number. But if we say C, there will be a problem, right? Because uh, type is not assignable because it doesn't match the signature. So if it doesn't match the signature, it automatically treats everything as unknown, so as any, actually not unknown. But we can do this. We can also join types. Let's say we have interface, I don't know, simple calc, and it says sum and subtract, and we have interface I complex calc, and it has multiply and divide, yeah? And we can say type calc equals this. And now we have everything provided for us, right? So calc, sum, and we already have everything. It's all typed in here. You might think that, okay, but can I merge interfaces? Yes, you can. But interface uh, calc extends. You can do this, but it will be an empty calculator in here. Sorry, empty bracket in here, which doesn't really look that well. And interfaces with empty body can be extended only if we are extending two or more other interfaces. So in here, basically, it would say, I mean, it doesn't say in here, but normally ESLint would tell you that you are extending only one interface and you're not providing anything. So basically, this doesn't strictly equal, but it does equal simply I simple calc. It's not the strict equal because, well, uh, but doesn't matter. Right, so we can merge stuff, right? We can also subtract things. So let's say type positive calc, and we want to have omit, and we want calc, and we want to omit multiply. So now const positive calc. Yeah, it only implements these methods. And if we say, I don't know, subtract, it can be defined, but it will guess that this is a number, and you're basically saying any. And it says that the this property doesn't exist on this type. Sorry. We want without multiply. Sorry. Body doesn't really matter. It will say that, yeah, it multiply does not exist in positive calc. And actually, I wanted to have subtract, but not important. Not important. Right. So what else can it do is we can have like an optional type. So let's say interface studio album, but it needs to be like let's say connected. So songs will be string like this, release date, and title string, artist string. And now we have interface live album that will not have a release date, but will have record date. And now we can say that type is either this or this. All right, so now if we create a const album, yeah, release date, but we can also say, let's say it says, so record is missing in type in live album, for example, right? So we can say that record date is new date, but we can also say what was it? Release date is also new date, and these are both valid types. I guess that's it for typing, right? I would say this is all for typing. So you can see it can describe primitives, it can describe more complex types, it can describe entire functions, it can join things, it can extract, remove things from an interface, um, it can merge interfaces. So that's that. These are a general look on types. In my opinion, extremely powerful tool in TypeScript. And one of the biggest reasons I like this language so much. TypeScript has a very robust type system. It's actually kind of surprising that it is that big, and it is surprising how little people are using it on a daily basis. I hope this video helped you a bit and you will be more confident in using different types of types in TypeScript. And bonus points if you can count how many times I said type during this video. Well, that's that. Thank you for watching and happy coding and happy typing.